Electromagnetic radiation. Electromagnetic radiation. Electromagnetic radiation. Electromagnetic radiation is a form of energy that is all around us and takes many forms, such as radio waves, microwaves, X-rays and gamma rays. In physics, electromagnetic radiation radiation or EMR refers to the waves, or their quanta, photons of the electromagnetic field, propagating through space, carrying electromagnetic radiant energy. It includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. All of these waves form part of the electromagnetic spectrum. Radiation that has both electric and magnetic fields and travels in waves. It comes from natural and man-made sources. Electromagnetic radiation can vary in strength from low energy to high energy. Radio waves, microwaves, visible light, and X-rays are all examples of electromagnetic waves that differ from each other in wavelength. These waves are also called electromagnetic radiation because they radiate from the electrically charged particles. Electromagnetic radiation is a form of energy that is all around us and takes many forms, such as radio waves, microwaves, X-rays and gamma rays. Sunlight is also a form of electromagnetic energy, but visible light is only a small portion of the spectrum, which contains a broad range of electromagnetic wavelengths. The spectrum is generally divided into 7 regions, in order of decreasing wavelength and increasing energy and frequency. The common designations are radio waves, microwaves, infrared, IR, visible light, ultraviolet, UV, X-rays and gamma rays. Radio waves. Radio waves are at the lowest range of the electromagnetic spectrum, with frequencies of up to about 30 billion Hz, or 30 GHz GHz, and wavelengths greater than about 10 mm 0.4 inches. Radio is used primarily for communications including voice, data and entertainment media. Microwaves. Microwaves fall in the range of the spectrum between radio and IR. They have frequencies from about 3 GHz up to about 30 trillion Hz, or 30 terahertz THz, and wavelengths of about 10 mm 0.4 inches to 100 micrometers μm or 0.004 inches. Microwaves are used for high bandwidth communications, radar, and as a heat source for microwave ovens and industrial applications. Infrared radiation. Infrared is in the range of the spectrum between microwaves and visible light. IR has frequencies from about 30 terahertz up to about 400 terahertz and wavelengths of about 100 micrometers, 0.004 inches to 740 nanometer or 0.00003 inches. IR light is invisible to human eyes, but we can feel it as heat if the intensity is sufficient. Infrared IR light is used by electrical heaters, cookers for cooking food, short-range communications like remote controls, optical fibers, security systems and thermal imaging cameras which detect people in the dark. Visible light. Visible light is found in the middle of the spectrum, between IR and UV. It has frequencies of about 400 terahertz to 800 terahertz and wavelengths of about 740 nanometers, 0.00003 inches to 380 nanometers, 0.00015 inches. More generally, visible light is defined as the wavelengths that are visible to most human light. Ultraviolet rays or UV rays. Ultraviolet light is in the range of the spectrum between visible light and X-rays. It has frequencies of about 8 times 1014 to 3 times 1016 Hz and wavelengths of about 380 nanometers, 0.00015 inches to about 10 nanometers, 0.0000004 inches. UV light is a component of sunlight, however, it is invisible to the human eye. It has numerous medical and industrial applications, but it can damage living tissue. X-rays. X-rays are roughly classified into 2 types, soft X-rays and hard X-rays. Soft X-rays comprise the range of the spectrum between UV and gamma rays. Soft X-rays have frequencies of about 3 times 1016 to about 1018 Hz and wavelengths of about 10 nanometers, 4 times 10⁻⁷ inches to about 100 picometers (pm) or 4 times 10⁻⁸ inches. Hard X-rays occupy the same region of the spectrum as gamma rays. The only difference between them is their source. X-rays are produced by accelerating electrons, while gamma rays are produced by atomic nuclei. The main use of X-rays is in medicine. A common application is in the form of X-ray machines, which take photos of a patient's body. X-rays can also be used to kill cancer cells. but also kill healthy cells, so must be used with much care. Gamma rays. Gamma rays are in the range of the spectrum above soft X-rays. Gamma rays have frequencies greater than about 1018 Hz and wavelengths of less than 100 pm 4 times 10⁻⁹ inches. Gamma radiation causes damage to living tissue, which makes it useful for killing cancer cells when applied in carefully measured doses to small regions. Uncontrolled exposure, though, is extremely dangerous to human. Gamma rays and X-rays, completely absorbed by the upper atmosphere, not available for satellite remote sensing.